Good morning, students. Only 30 students are joined. Around 40, 70, 30 only joined now. So please ask your friends to join. Srimati, is it audible?
Yes, sir, it is audible, sir.
You can see that window.
Yes, sir, method overloading.
Okay, good. We'll start now. Today the topic is method overloading. So the last class we discussed about operator overloading. Here now we are going to have that method overloading. Method means the function overloading. In C++ you studied that one, function overloading. Function overloading we see that one. That is same one. Here we are having method overloading. So method overloading, how we can do that method overloading is, here we have to vary the parameters. The parameter is changed, then here the parameter you call it as signature. So you have to have same signature as same parameter, then the corresponding method will call. So even though the name of the method is same but different argument, then we can call it as method overloading. Everyone is joined now. We'll start. Around 33. Okay, we'll continue. Okay. Method overloading. Here the simple example, we have that one. Now we see that one. Here we are having, here we are having that method with, to see this one, we are having the three arguments here, 10, 15, 20. Another one is three argument with different type. Next here we are having only one argument. Right? So we are having that one. You see, in that case, you have written a single function, then the function is going to work for all arguments, right? So here we see this one. In that case, what actually we have to do is a equal to none. So the argument. So these are the arguments. Self is its own, right? So here the arguments are a, b, c, right? Now you see this one. A is none. A equal to none. B equal to none. C equal to none. So here we have to give that one. If you are giving this one 10, 15, 20, now it will take that value. So a equal to 10, b equal to 15, c equal to 20, right? Now it will check that one. It's not equal to none, right? Then it will print the sum of the three arguments. If you are having two arguments, so here you have to check that one. A equal to a not equal to none, p not equal to none. So you are having three arguments, right? So here we are having, here next one is, if you are having single argument, it will give that error. Place enter two or three arguments, right? So here we see this one. We will execute that code. Right. I'll execute that one. I'll see. Right. Now you see this one. Here we are having this one as function. Now that function is calling now by different type of arguments. Okay. Here now this is actually we call it as here initialization. Initialization as here now you see this one none means nothing is there for A. B is none means nothing is there for B, right? Then here C is none means nothing is there, right? Now here we are giving that one this is 10, 20, 10, 15, 20, right? Now what it will do now, so just it is assigning for A, then this is assigning for B, second one, then third one is in that order only it will assign, third one is C, right? Now for the three arguments we are having values. So A none means nothing is there, empty. Now we are assigning that one, so it will join with refer one value. Next here B is none. None means empty. None empty means is not referring any object. Now here 15 is assigned now. Now it is assigned 15. So value is there. Next C we are having C is empty, right? Now here we are assigning now C equal to 20. So all are having value. So all are having value means now not none. Not none means it is adjoined with some value. So this is not none. Right? Similarly, B also not none and B also not none. So B also is having some value. Now C not none. So C also not having value. So here it will use that values. So 10, 15, 20. So here value 10, 15, 20. So 25 plus 20, 45 is so this one is printing now. Sum of 3 is 45. Next is the second case, we are having two values 10.5, 25.5, right? So this is actually tuck typing. So here we are having A initially in that method you don't have any value, is empty, B is empty, C is empty, right? Now here we are having that value as A is joined with now floating point number. So here B is having 25.5, 25.55. Now C is empty. C is none. Nothing is there. None. Right? So the first case is fail. This is failed. Next else if A not equal to none, P not equal to none. So A is assigned to first value, B is assigned to next value. Then C is none. So this case is accept. Now it will print sum of A equal to 10.5, A equal to 10.5, then here 25.55. So it will have that one as 36.05, it will print. Next one we are having only one value. So here this is to fail, this also failed, then it will go for else part. Please enter 2 or 3 arguments. So we are having summing that one, it should sum with more than one value. So single value is not used for summing. So here we are having that one, it print now. Right? So if you are having many arguments, in that argument some value is there, right? Then you have to assign the corresponding value, then remaining is none only. we can have now, right? Next, we see so we see that method overloading. Main method overloading is graduation. This is method. Next one is method overriding. Method overriding is here we are having that one as this method. One method is having defined in many divide in that inherited classes, right? So here this is base class area. Next one is derived class area. So here square is a space class. So in that one here square is a space class, right? From the space class we are deriving that circle. So from the class we are deriving the circle class. So this is the base class. In that base class we are having that one area, square area. Similarly, here in that your derived class also we are having that function method called area, right? Now here depends on the object we are having, then here it will call the corresponding area. Now you see this one here C is a object of circle, right? C is an object of circle. Now we are calling C dot area. Now the C dot area is actually it will call that C is a inherited object, right? Circle. So it will call this area. So we are having that value x is r now. So it will print the area. If suppose we are having the class is called here square is equal to square, right? Square with some value here square empty and a start area with some value 10, right? Now this s is here the object of square. Now we are calling that one as s dot area. So here it will go for square and it will print now the area of the square. Now we will see that one. Right. Here, now you see this one, we are importing that math. Importing math is actually here, this is like that include, right? Include that Conaiva.h, include standard.h, like we are having, this is math is a module. Math is a module, right? That module is include for the constant pi pi value. So 3.14, 3.1418 or something. This is defined in math. So here you have to use that one. So math dot pi. You are including that math dot pi, right? So or otherwise here you can do that one from math import pi. Here if you are using, you can directly you can use it as pi. So this pi is here, that value is from mathematics, right? So here we are having in that module, we are using only one constant pi, right? The difference between that two is if you are importing that math means you are importing total math, and on that math we are getting now pi, right? So that is previous case, right? So here we are having now here from math import pi. So we are getting now. So now you here you see this one. First C is having that one circle, right? Now here, right, next here now. Then according to that object, then it will call the corresponding function. So this is called method overriding. Overriding. Okay. So here we run that code. Method overriding. Method overriding. Now you see this one circle area. So first one is it calling with the circle. So here this is circle object is calling now. So it will give that one. Here what? How do you define that one? Circle, right? So here we are having now square. So now it will do that one. The square area 100. Right? Can you see the difference now? Right? In that one, I include one more important concept is here we are including total module import, right? So import as math. If you are having total module, on the total module, you have to take that one. So you have to add that one math dot py, right? This is the case. So here it will give the list of that function available, right? So here we are having another functions here now. You see the list of mathematical functions. So we can see that one. So these are all the mathematical functions. In that one we are having pi. So this is the pi value, right? So pi value is there. Then we are having the sign. We are having the square root or something. So whatever the functions we can have, now, right? So we are taking now the constant pi. Here we use equal, right? So the same one equal file save. Then you run that code. We are having that one, right? Otherwise, you want to use that. So what is the difference actually? If you are using calling the total module, your program is having your exe program is having a long one. It will include all mathematical module where it will take pi, right? Suppose you want to include one particular case. Now here itself you write that one from math import the corresponding right? So here you can use that one as math. So the difference between that one, you no need to use math, right? So you see proper difference. So here we have to use that one from math module. I want to import pi, right? In that case, no need to use math. Just directly you can have now pi, right? So pi is automatically take that value. So 3.14 or 18 something. Here we are having the corresponding value. So you see that one. You can use that. Yes. Both are having same yeah. Okay. So the difference between the two cases you take now. Is there any doubt here so far? You ask now. For this the two cases, if you are having any doubts, even though if you are using that CS yes instead of yes, you can use the C itself. So C is now joined with that square, right? So here is a parent class. So the same method we have that one. C Okay. Any doubts? Dear students, if you ask doubts, then I will explain that one. If you are having doubts, you can ask now. Dhananjayan, please respond. Dhananjayan. Ajay Kaudam, please unmute your mic. You talk with me. You are having a chance. Unmute your mic, Ajay. Ajay Kaudam.
No doubt, sir.
Okay, Priyadarshini. Thank you. Anybody? Arvind?
No doubt, sir.
Srimati, thank you. If you are having doubt, you can ask now. I will continue then some other topics. Bhupati?
Yes, sir. No doubt, sir. No doubt.
Okay. Now we will continue now. Here we will see some other topics. Some other example we will give now, that one. Right. In that operator overloading cases, just you see this one, I already given that map. Now you see that map. So here this is for plus, right? So for that plus, you have to use underscore, underscore, add, underscore, underscore, right? So the underscore, underscore is already, we are having that method, then that method is going to be overload, right? Method. So this one, here you have to use for multiplication, then you have to use that one, right? For division, you have to use true division, right? So this is called integer division. So what's the difference between integer difference division? That division means then the result is only the integer number. So you have to give the double slash, right? So this double slash is one operator called integer division. Then here you are having modulus operator. You have to use that one. Modulus operator is here you are having now. If you are having 7 modulus 2, it will give the result is 1. So remainder, right? So here 7 divided by 2. So 6 divided by 2 is 3. Remaining is 1. So the remaining is we are having 1. This is modulus operator, right? So 7 divided by 3 also we are getting now value 1, right? So power, double star. Then here we are having and cap is R. So this is actually bitwise and bitwise R. Now left shift, right shift. Do you have that idea of the left shift and right shift? Here if you are having number 8 with left shift 1, what's the value? 8 with left shift 1, what's the value? Any one of you? 8 left shift with 1, right? So here this is left shift, 8 left shift 1, what's the value? Anybody?
16, sir.
8 left shift 1, what's the value?
16.
How much?
16, sir.
16. How it is actually, you see that one. Everyone should know that one. Here left shift, that value is, here now we see this one. Right. Here how we are having now, so this is a bitwise left shift. So bitwise left shift means here 8 is in binary value. We are having now 1, 0, 0, 0. Right. So this is actually 2 power 0, 2 power 1, 2 power 2, 2 power 3. Right. So 8 is having now that value as binary, as we are having now 1, 0, 0, 0. Right. Now we are doing that left shift means, so we are shifting that one bit. This is 0. So 0, 0, 0, we are adding one more. Right. Now the value is, this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Right. Now the 2 power 4 is 1, then all others are 0. So 2 power 4 is 16. So we are getting now the result is 16. So the left shift is equivalent to multiply with 2, multiply by 2, right? Then what about that value? 8 left shift with 2, what's the value? Other than Srimati, any one of you tell that one, what's the value for 8 left shift with 2? Please students, please, you unmute your mic, you tell that one, you answer that one. Dhananjayan, Priyadarshini,
32, sir.
32, correct. So here you see that one. This is the value. If you are having one left shift, two left shift means we are having that value, one more zero, right? So 5 0. So 2 power 5. So this is we are having now. So 2 shift means it will add two zeros. So this is we are getting now. So this one as it will move that one, right? So here we are getting now 8 and 2 power 5. 2 power 5 is 32. So this is equivalent to multiplied by 4, right? So how many number of bits we are shifting? One bit is shifting means 2 power 1 is multiplied. Then 2 bit is shifting left shift means 2 power 2 multiplication. 3 bit shifting means we are having 2 power 3. So if you are using the 3, then it will give 64. Now we will see that one. Here now we are getting now as 1. Here now 2. We are having that value 2 means 32. Here we are having that one as 3, 64. Like we are. Then what about right shift? You see that one. This is left shift. Then if you are having right shift, what will happen here? So that 0 is here, that the last bit is removed, right? So here we are having now a right shift. If value 8, right? So this is the value. We are doing that right shift. The right shift means then that last 0, last digit will removed, right? So last one digit is removing. So we are having 100. 100 is what's the value?
4.
Tell
4.
me.
4, sir.
4. Correct. Here we are having now. This is if you are doing right shift. This is equal to divided by 2, right? So right shift with one bit. 2 bits mean divided by 4, right? So that cases now we are having now, right? So here 1, it will give that value as 4, right? So if you are having value 2, we are having now this one as here, right? So divided by 4, right? Suppose we are having number 9, right? So now here what will happen here? 9, that one, right? So 9 is here. we are having 1 0 0 1. That also if you are doing that one right shift, now it will get, now that 0 is went up, so we are getting now that value only 4 only. So this is equal to integer division by 4, right? So here we are having this case, here we are having now that value is 9 9 with, we are having right shift by 2, so divided by, right shift by 1 bit, right? So now it will give that value 4 only, because of, then that is truncate, right? The one is removed, correct? So we are getting now the corresponding value, right? Then what about that value for this one? 10 by 1, what's the value? What's the value is expected now?
5, sir.
5, because 1010 is binary number, right? So here we are having this value 1010 is for 10. Now we are removing the 10, the remaining is 101, so 101 is 5. So this is the case of left shift and a right shift. Okay, now we'll see that one. Yes. So operator overloading, we are having this the concept. So left shift and right shift also you should know that one, right? We already studied in C, but we'll explain that one, right? So here we are having this one as here we are having the minus equal to plus equal to, we are having that one, right? So this is, we are having that case A plus C equal to B, so that A is assigned that one, right? A plus equal to C. So here we are having now, let's see that one. So this is actually, we are having, we didn't so far give so far, so I give that one example. Here we are having A equal to 20 and B equal to 30. Now we are having A plus C equal to, means we are having accumulated addition, right? So A plus B equal to, this is equal to actually A equal to A plus B, we are having now, right? So we are doing that one. Next we are having that value for A is now 50. So this is, we are having here the plus equal to, right? Similarly that we can have these cases, minus equal to, star equal to, slash equal to, right? So this is, we are having the corresponding operate, the function is, we have given that one. So you add one more I, right? We are having this one, right? So here you have to use that operator also, can be overloaded. So many operators are there, the corresponding name is here, right? Now the unary operator, negative, here positive, then absolute value. Here you know that one absolute, right? APS is here, if you are having the positive value and negative value, it will give only magnitude only, right? So here we are having APS of minus 10, so it will give that one value 10 only, right? So APS of plus 10. So here suppose you want to have that one variable, then variable value, even though it may be positive or negative, we need to have that magnitude, the quantity, not that sign. Then you have to use that APS, right? So here if you are having 10, right? So here if you are having that value equal to A equal to minus 40, right? Now we have to use APS absolute, then we are having A, so it will give that one as 40 only. So even though it may be positive or negative, then it will give absolute is give only magnitude value. Magnitude value means it's always positive. This is the case of absolute, right? Here we are having that one invert. Here already discussed that one. So complex number, right? A equal to J, we already discussed that one, complex number. This is for conversion of integer, right? Integer conversion. So this int function is used for integer conversion, long function is used for long conversion, right? Then float is used for converting into float, then octal number for that case, hexadecimal for that case, right? So here you see that one, we can have now that one as here, you see hexadecimal value for this number, hexadecimal value for hexadecimal value for number. Here we are having that one as hexadecimal value 45, right? So here 2D, 2D is the hexadecimal value. 2. It's 16, 45. How do you get the 45 is 2D? Here 45, right? So divided by 16, we are getting now that value 2 times, right? Then the remainder is 42, 32, sorry, 45, no? 45. So here 45, 32, remaining 13. 13 is 10 is A, 11 is B, 12 is C, 13 is D, right? So 2D. So 2 is 2. So here 45 converted into hexadecimal value. So 45, so 2 times we are having now divided by 2, then we are getting now the remainder is, right? So combined together 2D. 2D is the answer, hexadecimal value, right? So this is the value we are getting now, 2D, right? So similarly, we can get octal number for the corresponding one. We are getting now that one, octal of 45, it will give the octal number. So octal number is represented by the 0 O, 0 O, octal number. 0x is hexadecimal number. 0 O 55. So 55, how we are getting now the 55 for octal number? Here we are having that one as 45 divided by 8. So 5 into 8, 40. The remainder is 45. 45. 5 remainder is 5. So you combine together as 55. 55 is a hexadecimal number, right? We can have now. Okay, once or otherwise we can have one more idea is here. So for D, what's the binary number is? Here one D is 13. 1 0 1 0 1 1 is D, right? For 2 is 1 0. Now you combine this 3 digit and 3 digit. 3 digit by 3 digits we are getting now as octal. So easily, if you are having hexadecimal number, now for that hexadecimal number, equivalent octal number, how do you get now? So here for each digit you have to give that 4-bit binary number, right? So this is here for 2 is 0 0 1 0. This is 2. D is C, okay, D is 1 1 0 1. So how it is? 8 4 1. So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Right? So here we are having 2 power 3 is 8, 4, 1. So 8 plus 4, 12, 12 plus 1, 13. Here similarly 2 power 0, 2 power 1, 2 power 2, 2 power 3. Right? So here we are getting now that one as 2 power 1 only 2. Right? So this is 2, this is D. Right? Now what we have to do is we have to join 3 by 3. So this is you take 3 and then another 3. So we are getting now, right? So for that 3 is 101 is 5. This 101 is 5. So we are getting now 55. This also one way of converting that hexadecimal to octal number. So we are getting now this is a manual work. Then here we are having the corresponding function we can use it, right? So these are all the operators we can have in the Python, right? So here comparison operator, we know that one less than. So comparison operator can also be overloaded. Then the corresponding that name of that function is here less than or equal to, equal to. Here we are having not equal to, greater than or equal to, then greater than. So for that corresponding function is this one, right? So here we are having less than or less than LT, less than or equal to LE, then equal to is equal, not equal to NE, right? Greater than or equal to, we are having that one, greater than, right? So like we can have the corresponding functions. So here, if you want to overload this one, you have to write that function for GT. Already discussed that one. These are all right. So here you see this one. We are having that convert that number is into float point number. So number we are having. This is a function my float. We are having that. Let's see. Any complex number is. One more example for operator overloading for that case. It now star is going to be operator overload, right? So here you are using your for your class we are calling this one as power. So this power is used for star, right? So you use the table power, right? So use the table. I'll give that file, right? Use the table. Now you see this one star is power. So you have to use this function. Use that function now, and we have to do that one power. Then you have to use self and other. Self is its own object. So A is that object. Next one is other. So it will take that value, the corresponding value, then it will give. So 2 power 10. 2 power 10 is 1024. File, save, right? Now you have to run that one. Operator overloading. Operator overloading. Here you run that code. So we have to print that one, right? Now here you write that one as print. Then only you can see that value. Okay, you run that code, right? 1024 we are getting. So we are using this operator now for your class. So it will take now instead of that you are having this is star, it will call this power, right? Now here A is 2, so self dot x is 2. Already we are having while initializing that one, right? So here while initializing that one, then we'll go for assign. Right here. So first we are having creating that object. So while creating that object, now for that A, it will create object class of I, its power, where we are having that one instant variable x is here, right? So x is here. Now for that x we are having 2, x equal to 2. Next we are having that B with 10, so it will create another object of that class. So here this class means its power, right? here also x power. So now this one as x equal to here 10. Now we are using that one, right? So we are calling this A. So A is now self. Calling this A. A is now self, right? The right hand side we are having B. B is other. So this self is A dot x. The other is P dot x. So A dot x is nothing but this x, right? Then P dot x is nothing but this x. So here 2, now it will use its own operator, right? 2 star 10. So 2 star 10 is 1024. So the 1024 is returned. So it will return now here 1024. In that place, it will replace that one as 1024. So the 1024 is printing now. We are getting now, right? It's printing now that 1024. This is the case now. Okay, like we can use that whatever operator you want to overload, we can overload the corresponding one, right? So unary operator also we can have that one. We see that code. So already everything is explained, right? Here we are having that unary operator. How do you overload? Then we are having. Right. For this program, what's the output expected? Anybody?
True, sir.
True, right? So here we are having this is 7, this is 5. So we are having that conditions is true. So it will check here. So it will check that one. This condition is true. Then it will return that true value, right? So we are getting now. So how we are going to overload that absolute, then integer. Here we are having here plus equal to we are having now. So if this one is going to have that one. So here now we are having that age, this one as plus equal to, we can have that one self dot ag and that one, right? So here if you are having that one, int nick plus equal to angel, then here we are giving that one as nick plus equal to angel, then what's the value it will print for here? In that case, nick plus angel, this one is plus equal to, so the plus equal to, it will call that one as this case, right? So it will add that one 7 plus 5, 12. So we are having that value is 12 now, it will print now.
Sir, it's Angel R, sir. You missed one A at the end.
A, which one? Here?
Last printing statement is, sir. Angela.
Angela, okay, okay. Last. Okay, okay. Angela, you are correct, right? So here it will have that, this is now that name, okay. File, save. Here we have to overload. Invalid syntax. So I add. Why it is giving that invalid syntax? Person is this one, which we are having now. Yeah, okay, plus equal to then make here we are having now. Let's see that one. Which means this is true. We are having Tom plus equal to then Tom. We are having now that one. That will continue now. And you see that control B. Now we are printing that one. Big dot B. Return that one, that value. So return that value is assigned to Nika. How it is return no, not defined by except that one. Okay, now you print that one, then this is something wrong they implement. You see that one. File, save, we run that code, it will give the true value. Okay, true value it will give. So this one is we are using that overloading of greater than operator, it will overload, it will give the corresponding result, right? Now this is we are having now it is getting absolute value. Then this one is here we are having IAD. So IAD is here they have given that one. So Tom plus that Michaela, then we are having the Tom. So it will print now. We'll check that case. So here we are having Nick plus dot equal to Angela. Nick plus sorry. We'll see that. Angela. So it will add the data. So here Nick going to have 7 plus 5, 12. So we'll check that one. Print. Actually print dot name. Self dot use, self dot use, self use. But there is different. No. Here is not assigning now. I'll check that. file save error. Yeah. So here it is giving that error actually. Why actually here now this one is wrong now. Wrong implementation. Check that out. So this is wrong. Here that implementation actually we require that one as here self dot a here plus equal to we have to put now plus equal to we have to put it now plus equal to we have to call then it will give that one self dot age is going to be have that more right now. Invalid syntax coming. This is wrong. Okay. Check that. Class. Now we will see that one. Let's see what we are. Here actually this is the wrong cases. Here the Nick is going to have that one as is not a class now. So Nick is changing that one. So this is wrong implementation. So you should not implement that one. So this is wrong cases. Right here actually they have given that one, but this is the wrong way. Now here we are having the Tom plus equal to that one. So now it is changing that object. This is a wrong way of implementations. We'll check that one. So here if you are doing that one, now this is converted into integer data type. Now here no longer as an object of person. So this is the case. Now we are having that one. So we are adding this to result. We are returning that integer value. That integer value is assigned to Nick. So now this particular Nick is going to convert it into that type of that class is integer. So that's the problem here. Now you see this one here. Now we are having Nick, right? So now you see that one type of Nick is going to have that change. So you have to implement carefully. So this is the wrong way, right? So class is integer. Now that Angela is type Angela. So you have to be careful. We have to implement as here Angela. Then here it will give now as this is we are having that person. This is person. This is Nick. Now we are doing that one. Why actually we implement like that? So we are implementing here. So how do you change that one as here if you are having that integer addition? So you should have that return type as here. You have to give that one as you have to create one object, right? So P1 equal to person, P1 equal to, you have to create another person, right? Now here we have to add that one. So here you have to give that one as here P1 dot P1 dot, here we have to give that one as P1 dot self dot age and other. P1 dot age equal to, here we have to give that one self dot age and other dot age, then return here P1. So you have to return the object. Then only now that object is going to have that one as here Nick itself. I think so. We'll check that one, right? So here you have to return that object with adding that age of that one. So now that object is going to convert assigned to another object. Now it will work, I think so. We'll check that, right? So here you have to print that case. So person should be unique, that one. Unique with, so here name and age is initially we are having 0 or something. So here we have to give person name also we have to give. Okay, this is not the right way of implementation, so you forget about that one. Okay, now if you are having any doubt, you can ask now, then you can leave. The last case, you should no need to include that one, right? So you have to concentrate on other cases. There is a wrong implementation. Any doubt you can ask now. Anybody else? You are having doubts? Here many students are not attending, right? So you have to inform that one. I will list out that who are not yet attending that one. You will see that. Okay. So we will continue the next class, right? So we'll go through that some remaining portions. We have to fill that one. Then we have to go for some revision and we have to do some exercise. By implementing some program, then you can get full idea about that subject, right? So whatever in that syllabus we have to cover and we have to work out. Then only we can get clear idea, right? Now you can leave. Thank you. Thank you. Any doubt you can ask. 5 minutes more. We are having that time.